Welcome to this talk on the triumphs and trials of mobile app development. This is my personal experience. To give you a bit of context, my name is Chris Light. I work at Esri, based in Cardiff in the UK. And I work with the runtime team. So with the release of version 100, I thought, wouldn't it be great to see what the code looked like from the other side of the code base and see what users kind of interact with. So I thought, why not explore the SDK and see what other users see? So I thought, why not make a mobile application? It can't be that hard. Everybody's got a phone, and let's explore it. So even though this is a talk about the mobile app development, I am using Android for my example. That's because I have an Android device. I've got a little bit of experience working with Android. I've used libgdx for 7 years. libgdx? Nothing. I've got no experience with the Android Studio, so this is my first time kind of diving into that as well. So I am diving into the ArcGIS SDK for Android completely fresh. My approach to learning is to take the manual and throw it away. So that's how I've approached this as well. I haven't read any of the documentation. I didn't look through any of the guides. I just wanted to see how easy it would be for me to pick it up from scratch. So if anything, this is very much an experiment in idiot testing, the ArcGIS SDK. And if anything, it's a lesson in that you need to read documentation. So is there anybody here who's got experience using Android? Okay, you're going to judge my code. So I've only got back into using Java quite recently. I'm mostly a C++ programmer now. Is there anybody here who wants to use and hasn't used the ArcGIS SDK yet for mobile devices? Okay, good. You're in the right place. So I hope from this talk you can take some wisdom and a bit of insight from my experience, and maybe you won't make the same mistakes that I have. Okay, so I'll just outline the project aims that I kind of set myself. This project took about 20 to 25 hours of work. Most of that time was spent testing, taking it out, etc. And most of that time was also spent tweaking the color scheme. Don't ask. So what did I make? Well, I'm very interested in GPS tools. I think it's absolutely fascinating that everybody has a mobile device. Everybody has a mobile device that can pinpoint you within 5 meters on the surface of the Earth, which I personally think is incredible, just incredible. So I dived into this project with no plan. I had no list of requirements. It was very much me exploring the SDK and see kind of what I come up with. So if you want to kind of like pit this into a development cycle, I suppose you would call it a user-driven extreme programming one. It was very chaotic at times. So like I said, I'm using the Android Studio. There will be links and a QR code at the end to the repository. And the compiled APK, the Android package, it's about 60 megabytes at the end. So what I'm going to do now is I'm going to show you a quick video of the app running, and then you can get an idea of what I've made. I hope this works. Okay. So this is what I've done. It's a generic GPSLogger. I've sped up this video because watching that is actually quite boring. So what I've got here is a foundation or a framework app to build on in the future. So it's mostly just a very simple generic GPS tool, like I said. The mobile screen capture is actually used for my Android device. This is because the emulated Android virtual machine, which you can use in Android Studio, I found that, was it stopped? Okay, I'll just let it stop. I found that the GPS playback wasn't accurate enough. I believe that it uses float values instead of doubles, and therefore it didn't look particularly well for presentation. So that's why I recorded a video. As you can see, there's a blue path. That is the tracked history of the GPS display. We've got green markers, which are kilometer markers. We've also got the developer pink markers, which shows minutes. So we've got 1 and 2 minutes up on there. Also on the top right-hand side, which isn't displayed, but there's a menu, and in that menu you have an option to start or stop the tracking, and you've also got some filter controls as well to remove, or shall I say hide, some of the markers. So you can just hide the path markers, or you can hide the GPS display, you can hide the distance or the time markers as well. And the other thing that this does is that it logs it out to a CSV and a GPX file. Which I will, of course, will go into more detail later. If you don't know what a GPX file is, if you go into Stack Overflow, I'm sure somebody will tell you to Google it, but it's basically an XML description of GPS locations and tracks. Most things consume it. I know that Android Studio consumes it for their GPS playback, and I believe ArcGIS Pro also consumes it as like, you can import it as like feature layers as well. So in my mind, after developing this, it's like a developer fantasy, as you will. In my mind, everybody enjoys this app. And we've got some lovely photographs here of people out running, being fit, enjoying all the functionality of the application. So, if anything, this proves that Photoshop is a really powerful tool. But let me go through my processes, triumphs and trials of diving blind into the Android ArcGIS SDK. So the first thing that I wanted to do, or first thing that anybody should really do, is create their Hello World app, in this case, Hello World map. Now, Android Studio is fantastic. It kind of handles everything. It handles all your dependencies, handles all your devices, including virtual ones. So to actually set this up was nothing. If you're using iOS, I believe it's CocoaPods, something similar to that. And pulling down the ArcGIS SDK was literally 2 lines in the Gradle script, which would automatically pull it down and build it. So there's no excuse for you there. And actually using it in the main activity, you just have to create your map view object, assign a map to it, and then display it. That is all you need to get a map up and running. Map up and running on the device. You can navigate it, you can zoom in and out, so on and so forth. So great, that's done. But I want to record the GPS location. And this was actually surprisingly easy. The biggest challenge that I had here was to make sure that the permissions were correct. You need to make sure that your manifest file is all set up with the correct permissions for course display and network permissions, and using your GPS device permissions. Once that's set up in the manifest, it was quite easy to kind of lever that in the code. So what we got here? We got the manifest on the top. And down at the bottom, just to get your display up, it's as simple as setting up your location display as start async. With that called, your graphic, everything will be handled for your location display, including the accuracy of the location display as well. So another thing to note here about location display is that there are several different types of navigation modes. There's like compass mode, there's like a follow mode, some others. And you'll see later I introduce a button that will automatically, or you saw earlier rather, you press a button and it will automatically go back and focus on your location display if you pan away. The other thing to note here is that the projection mode for the GPS location is quite important. So you have to set the GPS location mode to be WGS84, and that ensures that the rendering position on the map for the location will be correct. So as you can see here, I've got a rudimentary path, of graphic path. I will talk about how I did that now. So to set up the graphics, I know this code is quite difficult to read, but trust me, it's fine. You have to create graphics layers to store like all your different graphics on. So I've got a path layer, I've got a marker time layer, I've got a distance layer, and I've also got milestones as well. So once you kind of got that set up and then assigned to the map, all you need to do is start populating it with the graphics that you want. So to create the polyline, all I had to do was create my polyline object, which is a collection of points, which I just collected from the GPS location. Create a description of that polyline. So we've got a blue one here. And then create the graphic polyline, which is basically taking the description of the graphic and the collection of points and then merging it into one object. And then all you have to do then is just add it to the layer, and you've done. You put it on the screen, and it's all ready to go. So if anybody was in Ewan's talk yesterday, you would have realized that geometry cannot be manipulated. This is something that I found out the hard way. During a hackathon over Christmas, we spent hours trying to solve this, and we realized that we couldn't. So the way that I'm handling this is probably the way that you should handle it as well, maybe, would be to clear the layer of the graphics and then redraw the polyline. If anybody has a better solution, then please let me know. Okay, so polyline drawn, I wanted to get the markers drawn, and it's exactly the same process as getting the polylines down. To create it, you just need a description of your graphic. You need then create the graphic symbol, which is taking the location point, which is X and Y, and then also the graphic description, and then there you have a graphic marker, which then you can feed back into your layer. You just assign it back to your layer, and it will pop up in your map. Working with text is exactly the same way. You just create a text symbol instead of a graphic symbol. You give it the string that you want to present, and then you kind of feed that onto your marker. Now, as you can see from the screenshot on the right-hand side, I came across a bit of an issue. Going on a long journey, zoomed out quite far on the map, you can see that all the markers have kind of like converged over each other. And to be honest, it is a mess, and it has no value really. So the solution that I found, by accident by the way, was actually using scale ranges. Now, every layer can be assigned a scale range. A scale range is the description of if a graphic layer is visible at a certain zoom range on a map. So what I then had to create two more layers. I had to create a layer for the milestones, for my distance milestones, and a layer for my time milestones. So every 10 minutes, every 10 kilometers, I would move that down to my milestones layer. Therefore, that kind of opened me up to assign a minimum scale range to the other markers between those milestone markers, if you understand me. Okay, good. That's when I came across my performance issue. I was getting a lot of lag. So when I was kind of running for about 20 minutes, my journey was about 20 minutes, I was getting a lot of render lag, so it was very difficult to navigate across the map. It was choppy, it was laggy, display location wasn't working correctly. And I kind of thought this was down to the overlay, the graphics overlay for the path being way too complex, too much fidelity. This is because the location display calls back every time that the location changes, and I was logging the GPS location every time that happens and then plotting that onto the map. And that happens about every half a second, sometimes a bit quicker. Depends on your signal, depends on how many buildings there are around. So the way that I kind of like got around this was by creating a buffer of GPS locations or points, and then taking this buffer and processing it, and then averaging all the points, and then this point that came out of the average was now my new location that I want to plot onto the map. And I was actually quite triumphant in this. I was quite pleased. This worked quite well. It smoothed out the tracking path, the route, and also solved my performance issue. However, I did find that after I implemented this solution, that I wasn't clearing the graphics layer correctly, which probably was the reason why it was lagging, not so much the fidelity of the GPS locations. But if there's anything that I've kind of taken away from this project, it would be buffering your GPS locations, then choosing the best ones out of that buffer, and then marking that one down on the map. So I kind of found that the best time to do changes to the buffer was about 5 seconds. Now, if you're moving faster, then you might want to reduce that time. But for cycling and driving a car at 40 miles an hour, I found 5 seconds to process the buffer quite useful. Right, so now that I've got my GPS locations down and it's pretty accurate, I want to record it. Now, I'm not going to go into too much detail here because I'm not using the ArcGIS SDK for this. I'm using the Java Outstream. For iOS, I'm sure you would use your own, use the iOS Outstream. I don't know what that is because I'm not an iOS developer. One thing that's important here is, for Android at least, is to make sure that your permissions are set up for storing to the external storage. And what was the other thing? Yes, and make sure that the route path is set up correctly so you can export your files to that location. I found that on a tablet and on the virtual machine or using Android Studio, I wasn't able to save those files. It's probably just a settings thing. I didn't look into it that much, but on my phone it worked absolutely fine. So the files that I'm actually logging out here is a CSV file and also a GPX file. Those are kind of custom made, so I just had strings that kind of like build the XML stuff. There's nothing special. The file sizes for each log was about 30 kilobytes per 5 minutes. So it's actually quite small. Right, well, now onto the big one, and that is calculating speed and distance. So it turns out one does not simply calculate distance on a sphere. So I had to learn very fast about something called long circle distance, which is like the Haversine function. I couldn't use Euclidean distance because it's a sphere. So I consulted Wikipedia and spent about 6 hours building my function and then testing it, which took a long time. But in the end, it worked well. I managed to calculate the distance, and therefore I can calculate the speed as well. There was a little bit issue with the accuracy, though, of calculating the speed, but that was fine. And then I kind of found out that the ArcGIS SDK handles this. So I literally spent 6 hours learning about maths, which is not a bad thing, but I could have just used the ArcGIS SDK. So what we got here is that you can just ask the display location to get your velocity. And that velocity is actually pretty accurate. As soon as you got your velocity, to work out the distance, all they had to do was take the delta time between update frames to the changes in the location, and then times that by the velocity. It's the exact same method that you would expect in a time-constrained movement that you would see in a game or any simulations. The text view, these text down the bottom left-hand side, this text view, has nothing to do with the ArcGIS SDK. That is Android only, the Android standard library. Okay, so with that done, I wanted to add something which is a little more relevant to this talk, because we are at Dev Summit, not User Summit. and that is adding portal items. Now, portal items are really easy to add, so there's no excuse if you want to use them. All you have to do is when you create your map, you're just creating a portal object. You pull down the ID, and then you insert that into your map, and there you have your portal item displayed on your map. So, in conclusion, jumping into the ArcGIS SDK for mobile, particularly Android, was a triumph for me. The interface to working with the ArcGIS SDK is quite simple. There's really good performance there. One thing that I did learn is that if you want something to exist in the SDK, something to help you, then actually it already exists, but you're not looking in the right place, which kind of leads me on to read the documentation. The guides and the labs that they got online are actually really, really good. And actually going back to them and going to some of the talks around here, I wish I did that before I started that, but my excitement got the better of me. Expanding this application, something that I would probably want to do in the future is push portal items back up. So recording my log, and then I want to push that back up to the portal and then use it as a web map, and maybe something we can do there. That'd be quite cool. Also sharing locations and paths with other devices in real time might be very interesting to explore. Something I'm not entirely sure how to do off the top of my head, but it'd be very interesting. And also you can just, make another generic fitness app. Something that else you could do. So I hope that there is some wisdom, some insight that you can glean from this talk. If you've got any questions about anything from here, I can answer them now, or you can come up to me later and you can ask me then. Is there any questions? Yes? Right, so the question was, what problems did I have with floating doubles with the GPS positions, right? So, sorry? I was using in the virtual machine, in the virtual Android machine using Android Studio, you can insert GPX file to read the GPS locations and feed it back onto the device. But what I found out was that when doing that, the values were float values, not doubles, so therefore the accuracy wasn't correct when walking. Is there any more questions? Okay, well, free to leave. There is a survey that I'm supposed to plug, that you're supposed to use it, I suppose. But other than that, thank you very much.